Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your method of analysis and testing of fats and oil. So in today's lecture, what should we are going to study? We are going to study about the different method for the analysis and testing of fats and oil. See, analysis and testing of fat is very important. Analysis and testing of fats are very important. Why it is important? See, if the fat and oil are in bad quality or maybe adulterant, then it will cause a health effect to the human being. Okay. Uh, that you already hear about it that the oil cannot be fried more than 3 times. Okay. So for a frying purpose, we are not using the oil more than 3 times because of the different compound which come into that oil, and that's why the oil become a adulterant. So that's why we have, it is very important that we have to analyze the fats and oil, and different tests should be performed for checking the quality of the this fats and oil. So in today's lecture, we are going to discuss about the different method of the analysis for the fats and oil, and even the testing for the fats and oil. So let's start today's lecture. Method of analysis of fats and oil. The main organization that develop or validate the method for fats and oil analysis, it included IUPAC, which means, sorry, International Union for Pure and Applied Chemistry. Okay, so the first organization which developed the valid method for the testing of the fat and oil is International Union for Pure Applied Chemistry, that is your IUPAC. The second organization is International Organization for Standardization, that is your ISO. The third organization is Association of Official Analytical Chemists, that is your AOAC. Then next is your American Oil Chemist Society, AOCS. Then next is American Society for Testing Material, ASTM. The next is your Association Française de Normalization, AFNOR. Next is your British Standard Institution, BSI. Detached Institution for Normong, DIN, and the Federation of Oil, Seeds and Fat Association, that is your FOSFA. In addition, there is an increased trend for the various national standard institution that develop their own standard, and this standard are based on a standard ISO methods. These are generally adopted as a official method. Okay, so after all these organizations that I already told you, IUPAC, AOAC, ASTM, BSI, AOCS, DIN, ISO, AFNOR, and FOSFA. Then there is a various national standard institutes are also develop their own standard for the analysis of this fats and oil, and these standards are totally based on the standard of ISO method. But now these methods are generally adopted as a official methods. In the United States, most of the analytical and test method are described by a AOCS. Okay, so if we talk about the United States, then most of the method for the analysis of the fats and oil and testing for the fats and oil are described by the AOCS. These well-established test procedure have afforded and advocate quality assessment of the raw material or end product or both. Okay, so in that various tests are adopted for the assessment of the raw material or for the assessment of the end product, and even some tests are common for both the test for the raw material and for the end product. Now, selected analytical method are adopted by the AOCS for the identification of the type, determination of the composition, detection of the additive, physical properties, stability of the fat and oil are summarized below. Means that in the next slide. These methods are also subjected to the use of the prescribed equipments and techniques of the sampling and testing as specified by the AOCS. So the different method which is used for the analysis of the fats and oil, they are prescribed that they should use the sampling technique and the equipments and even the different techniques which are specified by the AOCS. It is very important. So in United States, the total analytical method and the testing method of the fat and oil are based on the AOCS method. Now the next one is your identification and the compositional analysis. So the following older well-established method which are based on the estimation of the selected functional group or the calculation of the oil or fat content are still used in the differentiate oil or fat. However, more accurate and faster analytical method like your gas chromatography of fatty acid and HPLC of the triglyceride now reduce the significance of these older method. Okay, so uh, before the faster analytical method are introduced, the older methods are used. That means that the estimation of the selective functional group or the calculation of the oil or fat content by using a differentiate oil or fat. Now faster analytical methods are introduced which are more accurate like your chromatography of fatty acid, HPLC of the triglyceride, and they will reduce they reduce the significance of the older method for the analysis of the fat and oil. The first one is your saponification number. So this is the weight of KOH that in milligram which is required to hydrolyze the 1 gram of sample of oil or the fat. Saponification number is simply what? Saponification number. It's simply what? It is the amount of KOH is required in milligram so that it hydrolyze the 1 gram of the sample, either the oil sample or the fat sample. Higher the saponification number, lower the average molecular weight of the fatty acid. If the saponification number is higher, then it automatically lower the average molecular weight of the fatty acid in the triglyceride. Now in the next table that is called a 4.12, describe the various saponification number of oil and fats. So this is the table. See, this table is for both iodine number and the saponification number. So here the first is for oil and fat, and then this is for a iodine number, and this is for a saponification number. So coconut have the first sample is what? It is a coconut. So with the iodine number 256 and saponification number 9. Palm kernel, iodine value 250, saponification value 17. Cocoa, iodine value 194, saponification value 37. Palm, iodine value 199, saponification value 55. Olive, iodine value 190, saponification value 84. Olive, iodine value 192, saponification value 156. Peanut, iodine value 225, saponification value 30. Sunflower, iodine value 190, saponification value 132. Soya, iodine value 192, saponification value 134. Butter, iodine value 225 and saponification value 30. Now in the next slide, I'm going to describe you the iodine number. Saponification number is clear. The amount of KOH required in milligram so that it will hydrolyze the 1 gram of the sample. Acid value. This value is important for the determination of the free fatty acid. Okay, so acid value is used to determine the free fatty acid present into a crude and refined oil. In both type of oil. It is the number of milligram of KOH needed to neutralize the organic acid present in 1 gram of the sample. Okay, so in saponification value, KOH required for hydrolyzing, but in acid value, KOH required in milligram so that it will neutralize the organic acid which are present in 1 gram of the sample. Okay, so free fatty acid is also calculated as a free oleic acid and reported as a percentage. The acid value is also determined by multiplying the free fatty acid with the factor 1.99. Okay, so if we have this percentage of the free fatty acid, then it will be multiplied by 199 and we get a acid value. Next is your iodine value. This value measures the unsaturation of the oil. Okay, for the measurement of the unsaturation in the oil and fat, we use the iodine value in terms of the number of gram of iodine absorbed per 100 gram of sample. Okay, so iodine value is defined as a number of gram of iodine absorbed by 100 gram of sample. Okay, and it is used for the measurement of the unsaturation of the oil. This method is applicable to all type of the normal oil, fat, but it will not contain a conjugated system. And some iodine value of various oil and fat are already discussed in the previous table. Hydroxyl number. This number reflects the content of the hydroxy acid, fatty alcohol, mono and diacylglycerol and free glycerol. Okay, what this is called a hydroxyl number. Now the next is your color reaction. So some oil also give a specific reaction and this specific color reaction are due to the presence of particular ingredient. Okay, color of the oil is due to the presence of the particular ingredient. The Halpin test is used for detecting the cotton seed oil is one of the example. Okay, Halpin test is used for the determining of the color in the cotton seed is the one example. This test is also estimate this test estimate the presence of the cotton oil in vegetable or animal fat or oil which are result of pink color form between the reagent. Okay, if the cotton seed oil are mixed with vegetable or animal fat or oil, then it will give a pink color when our reagent are used, and the reagent that we use for this reaction are called a sulfur and carbon disulfide and cyclopropanic fatty acid. They are normally present in a cotton seed oil. Now, composition of the fatty acid. Either Saturated fatty acid or unsaturated fatty acid both contain carbon atom 80 to 24. In animal fat and vegetable oil, marine oil and fatty acid are quantitatively determined by the gas chromatography. Okay, so either it is saturated fatty acid or unsaturated fatty acid, both contain a 8 to 84 carbon number. Okay, either in animal fat, vegetable fat, marine oil and fatty acid, which are quantitatively, and this fatty acid are determined by the gas chromatography, and it is determined quantitatively, not qualitatively but quantitatively, means that the how much amount of fatty acids are present after the conversion to their methyl ester form. However, free fatty acid analysis is also possible by using a specially selected stationary solid phase. A capillary gas liquid chromatography method is also used for the measurement of the fatty acid composition and level of the trans unsaturation and cis methylene interrupted unsaturation of vegetable oil. Coupled HPLC gas chromatography method are used for detecting the adulteration of oil and fat. If we have to detect the adulteration in oil and fat, we use a coupled HPLC and gas chromatography. Then the identification is done by analysis of the unsaponifical minor constitute which is specific to a particular oil or fat which shown in the next slide. Here the minor constitute analysis and the identification. The first one is your squalene, olive oil, rice oil and fish liver oil, campestorol or stegmesterol. Identification: cocoa butter substitute, carotene, raw palm oil, gamma beta tocopherol, corn oil, gamma tocopherol, wheat germ oil, alpha gamma tocopherol, sunflower, gamma lambda tocopherol, soybean oil, cholesterol, animal fat. Physical test for the identification: specific density, index of refraction, color, viscosity and the melting point test are used to identify the fats and oil. The onset, flow point and the temperature range over which the melting occur are the indicative of the specific number in the fat. They are also used to determine by the standardized procedure, that is your solid fat index or the estimate of the um, percentage of solid in case of semi-solid fat on the basis of changes in volume with the temperature. This is the important in case of fat hydrogenation and interesterification process. Quality control test: there is a number of the analytical method which are used for the checking the quality and deterioration in the oil or fat during the refining. Okay, and these changes are occurred due to the storage condition, and the method that we use for checking the quality control are discussed in the next slide. Now see what is written in a slide. The number of analytical methods are used for assessing the quality and deterioration of oil or fat during the refining and the subsequent storage condition. This method are summarized below. Lipolysis. Okay, so lipolysis is used in case of free acid result from a lipolysis of oil and fat. This is determined by the free fatty acid or the acid value. Okay, lipolysis are determined by the determination of the free fatty acid or the acid value. The crude oil and the animal fat are usually have a exceed 1% of free fatty acid, and the free fatty acid is lower to less than 0.1% in case of refining of oil or fat. When we refine the oil or fat, then the concentration of the free fatty acid will also decreases in case of refined oil or fat. peroxide value, the oxidation of oil and fat, which leads to the formation of hydrogen peroxide. This hydrogen peroxide decomposes and produces the aldehydes, ketone, and other volatile products. Okay, when this hydroxide are decomposed, they form what? They form either aldehyde, ketone, and other volatile product, which are the characteristic of the oxidation rancidity. And this method is used for the determining of the peroxide concentration, which are based on the reduction of the hydroxide group with Hi or Ki, and it is liberated free iodine, which may be titrated. The peroxide value are expressed in terms of milliequivalent of the iodine form per kg of the fat. And the last one is your shelf stability test. It is predicted by the active oxygen method, that is also called a AOM. The fat or oil are subjected to an accelerated oxidation test under a sterilized condition, so that the sign of the deterioration are revealed within a several hours or day. Then the sample are heated at a temperature range of 97.8 degrees Celsius and air are blown through it. Then this active oxygen um, method value are reported as a term of hours, so that it will reach that peroxide value 100 milliequivalent per kg. So this is all about the today's lecture. I hope you will understand. If you have any query related to this topic, you can ask me in a comment box, or for a further detail me on different platform like Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or for any query, you can also ask your query to the helpline number that are already mentioned in your slide, 7080833450. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.